Okay, so let's take a quick peek at this problem. A young woman and her boyfriend plan to elope, but she must rescue him from a mother whose mother was locked him in his room. Um, the young woman has placed a 20-foot long ladder against his house and is knocking on the window when the mother begins pulling the bottom of the ladder away from the house at a rate of 3 feet per second. So I have in my little picture here, you can see I've called the ladder we know is 20 feet. And in your work, I believe you called that C, so I labeled it C as well. I'm showing that the rate of change, she's pulling the ladder away from the wall at a rate of 3 feet per second. So I went ahead and showed that with this little arrow. And now it's saying, how fast is the top of the ladder falling? So the question is, this is our question, how is the change in height over change in time, how is that changing? When the bottom of the ladder is X number of feet away. So we'll maybe call this X for the distance away. So therefore, my formula, I need to find dH dt, and notice they've already given me dx dt. So therefore, if I can create some equation that relates h and x, and then take the derivative of it, I've got what I need, and I'll get what I need. So what I've got is a squared plus b squared equals c squared, Pythagorean theorem. So we'll do h squared plus x squared equals c squared, but the good news is we know c is 20, and it's okay for me to fill in that variable with the number because it's a constant. The ladder is not changing its length as it falls down the wall. It's staying 20 feet the whole time. So we can go ahead and fill that in. So 20 squared is equal to 400, but the good news is once we take the derivative, this is going to give us 2h dh, try again, dh dt plus 2x dx dt, which is equal to, well, the derivative of a constant is always 0, so therefore it's 0. So now the question's asking us to solve for dh dt, so we can start filling things in. And solve for dH dt, I guess let's start with that. So that'll give us 2h dH dt is equal to negative 2x dx dt. Now solving for dH dt, I need to divide by 2h, so that's going to give me 2 dH dt is equal to negative 2x divided by 2h, all times dx dt, and the 2's would divide, leaving us with dH dt, the change in height with respect to time, is equal to negative x divided by h dx dt. So if I'm able to change in the length of which the ladder is changing with respect to time, the way it's going away from the wall. So we start filling things in and see what we need, what we have. So our goal is to solve for dH dt. X. Do I know how far away the ladder is from the wall? Well, for part A, it's 12 feet. So therefore, I immediately know, I'll do it here, X equals 12. So therefore, I'm going to go ahead and fill that in. Now, the height of the ladder, we don't know that. But if I know the bottom of the distance from the wall to where the base of the ladder is, that's 12 feet, and I know the hypotenuse, the ladder itself, is 20 feet, I can figure that out by using a squared plus b squared equals c squared. So therefore now I'm going to get 400, b squared is equal to 400 minus 144, which is going to give me b equals the square root of 256. The square root of 256, thank goodness, is a nice number. That's 16. Excuse me. So therefore, I don't know why I used b, silly me. I should use x, duh. Or sorry, h, right? That's an h and an h and an h. So therefore, I know my height is 16. Okay, so 16. Then the rate at which the ladder is being pulled away, well, that was right here. Right, they already gave that to us. The ladder is being pulled away at 3 feet per second, so we'll go ahead and fill that in. And always on these related rate problems, ask yourself, is the change in x a positive number or a negative number? As the ladder is getting pulled away from the wall, it's getting further away, so it's a positive number. X is increasing. So that's going to give us dh dt equals, and then we can kind of simplify this up and multiply through, simplify it up. So that's going to be 3 times negative 12, which is negative 36. Negative 36 divided by 16, so that is negative 2.25. And I want you to ask yourself, or 2 1/4, I want you to ask yourself, does the negative make sense? Is our height negative? Is our height going down? Yes, it is. So therefore, this makes sense. So there's our answer. The change in height, excuse me, well, we should put units on it, is negative 2.25 feet per second. All right. And then, so then for part, your work was good. My issue came in with, I just think you switched your X and your H. I think you misinterpreted where the 12 was going on the triangle, which kind of changed all of your work. But aside from that, you had the right idea, and so it just ended up making your, and you did your derivative in a way where you had solved first, then took the derivative, so it just made it a little, I don't want to call it a little less messy or a little less clean, because it's all a matter of opinion, but it all looks right. Your big issue, I think, was just how you interpreted your that 12 feet. So I hope this video helps. And then part B, part C are the same thing, just one of them 16 feet, one of them 19 feet. So your numbers just get more and more messy, but it's the same calculus.